So let's continue with our fundamentals of NumPy. So again, as a recap, NumPy is a numerical Python package that is very good at handling large arrays of whatever dimension. And then all of the linear algebra that comes with handling large arrays, which are vectors, and two-dimensional and higher dimensional matrices. All of that is built into the package, and it's optimized for efficiency. What really it actually, it uses another compiled language, which is C and C++ underneath to run those programs efficiently. Now, before we get to actually taking a look at how efficient or not the routines are, we need to figure out first how to actually enter and work with NumPy. So first task in any kind of programming is getting your data in some sort of shape and format that you can work with. So right now we've been going through the ways to define my data arrays and then slowly manipulate them one by one. So we're going to continue doing that today. So if you can open up your Spider environment, if you can open it back up to where we were, that'd be great. If you save, hopefully, your Python file as .py, matrices underscore numpy.py is the last thing I saved. Or if not, you can go to the files that I posted, Python scripts, and it's called Lecture2 vectors and matrices, and that has kind of like a list of all of the things we've been doing. Though one thing that I do in class, I sometimes just act on my own, so I'm never going to repeat precisely line by line what's in those files. I kind of use them often just as a motivation, and I might type in some matrix on my own. What I type in as a matrix, it doesn't matter. It's important that we work through the details. So if you can open those and either execute them again, or if you have to open Spider back up after being closed, or if your computer rebooted, then you kind of have to execute things again in order to get them in memory. And you will know that by monitoring here the situation, like what are the variables you have in memory, right? If you have nothing, that means that you're starting from zero and you need to start again. Now you can execute the file either by, let's actually do this one, okay? So if I execute it, I can click on this, and Python is actually nice enough to print out in command window what is actually executing when I click on that button. So the command that is executing is called run file. Okay? The first part of it is name, the full name of it. And this is a working directory. So in case you're actually printing anything or printing anything to a file, it's going to go into this working directory that is here. And this is just my local directory. For you, all of this is something else. I'm going to comment on something that I suggest you do, simply because computers go out of function for all kinds of reasons, and this is not necessarily specific for this class. All of the work that is important to you, keep in a cloud. So some sort of service like Dropbox or UTBox. So UT has something that is available to you as students. I'm using UTBox. And I'm using it so the files are syncing to my computer, so it's implemented on my computer too. And whatever I write is getting, as long as I'm on wireless, is going to get synced. So if this machine, if one of my toddlers, and I have two in the house, so there's dangers abound to my computer, okay, in the house, if one of them spills something, or I get some peanut butter on the computer, as often is the case, and this computer stops working, things can sync, and I can go to my files, and I can literally log into this machine and continue lecturing because all of my important files are up there. So it's kind of very important, and you can actually sync it to your phone, to your computer. You can choose what are you syncing to your computer versus what you're not. At this point, I have terabytes of research data. Not all of it is synced to my computer because this is actually a feeble machine and it doesn't store a lot. Okay? And I can actually select what am I syncing which semester based on what I teach. So I highly, highly suggest that you do that.
Is there exactly the canvas, the icon available for you?
Possible. I call it. I just went to IT. It's UT Box. It's called UT Box.
UT Box.
So it's a type of a cloud service that is specifically specialized for UT campus. As you graduate, you will be able to migrate that data and download all of it. But it's important that then you're not so much linked to which machine you're on, because again, computers break down for various reasons. And I will also advise you that everything that we work through, so obviously I have in that UT box, I have something called PGE310, I have lectures in there, I have lectures, these happen to be 2018 fall, 5-minute scripts, okay? But I have them for spring as well, yes?
Sorry, not related to the mood. Where do you
You just place it here on the side.
Oh.
Yeah.
Give it to me after the class.
After the class is just fine, you just place it there. Yeah. So keep your files organized, and I would call that computing hygiene. Okay? And this being a computer-based class, I think I should point out things that will save your sanity down the road when things break down. Okay? So keep them organized, keep them backed up, because data does go away. So this way, you're also, if something happens and you forget your computer that day, you can log in from anywhere, you can log in from a browser, and you can download the files. Okay? So that way, you're not tied to the machine that you're working on right now. So that is a mobility that hasn't been there 5 years ago, okay? And things are rapidly changing, so it's actually quite amazing. So use it. Okay? Now, back to where we were. So you can run those files. The simplest way to run it, since you're in the same directory where the file is you could just say run file and then in apostrophe just the name of it. And since we're not writing anything from this file, it doesn't matter that you give it the working directory. So either way you run it, and when you run it, then things like importing numerical Python are already done for you, and we already have this matrix A, or this one is the memory. Note that if I have it twice, then second time I'm overwriting whatever there was, and computer will never know, programming will tell you, oh, by the way, you're overwriting something. They're just gonna assume that you know what you're doing, so watch out. Okay? All right. So let's just quickly print this A, and I'm going to actually print it from command line just to see what I have. Okay. So this is a 3x4 array. Okay. So if I want to grab this element 23, what do I have to type? Print. What should I print? Row is
1.
0.
1. It's the second row, but we start from 0. So that the little -1 computation has to go in your brain. So this is row 0, row 1, row 2. So it's row 1, and column is 2.
2. Right. We also start from 0 with columns. Right?
Precisely, with everything. So let's see. And then we have to check that that's indeed correct. Okay, got it. Okay, so that's how I grab it. Now I also want to, we said that we can inspect shape of this by typing shape, a shape. Or I can even just do this, np shape of A. So one thing that we're learning as we go is that there's typically multiple ways to do this. This first one, this actually means, so there's a notion of a class that is not just data type or data structure that I have, which is my matrix A, it is not just this array, but there's also a number of functions that travel along with that structure, that work with that structure. So that is called a class. Okay? So you just have to know that not more than that for now. So basically, there is a shape function that is working with the arrays, and I can call it this way. There's also shape function outside of that is possibly working on class A, but possibly on some other classes as well. And then I'm saying np.shape of A. Okay? So this is possibly working on multiple classes, but when it recognizes A, it's kind of working in the same way as this one. So this is really equivalent to things in terms of the result. It's the same thing to write. So my point being is don't be upset if there are multiple ways to do things. That's simply the way it is. Last time we had, like, what was it, A cosine function?
Yes.
Math or NP or whatever it is, right? Doesn't matter, there's multiple. What matters though is that you have to be sensitive into the sense that they could work slightly differently. And that is this modularity. You could come in and say, I don't like the way this function works, I need something else. I'm going to define my own, okay? And you're going to create your entire new module that has a function implemented the way you need it or the way your data requires, okay? And that's this modularity, and that's what we need to do. So things kind of grow and change as we go. Okay. Now, not only I can actually print the shape, I can actually change the shape. So I could actually do the same, the following. I have 12 elements here. Okay? I could say, hey, let this shape be 112. And then I'm going to print my A. And suddenly, all of them are in one row. So I have redefined this matrix. So it's a matrix, actually. And it has one row and 12 columns. Now, what did it do precisely? If you notice, my first row was 11, 12, 13, 14. So I can see it here. Then after that, I have a second row. What used to be the second row. And then I have the third row. Okay? So basically, it took the matrix A and it put first row here, second row here, third row here. That's called row-wise operation. So it's basically just filling elements it has row by row. I can do anything I want and change shape any way I want as long as the total number of elements is not changing. So I could actually say here, hey, A.shape is, so this is 12 elements. So I could have 1 times 12, 2 times 6, 3 times 4, 4 times 3, and so forth, right? So whatever comes down to 12 works. So I can actually just say, hey, let's do 6, 2. Okay? And then print. Now it took whatever it had. It started filling first row, but I told it, hey, you gotta have 6 rows, 2 elements each. So it just went down this list and said 11, 12 is the first one. Oh, I gotta go to the new one. 13, 14 is my second one. 21, 22, and so forth. Okay.
6 rows and 2 columns.
Yeah. As long as you have enough elements, it's gonna do it. And often you will have to reshape the data. So this is going to come in handy, and it's going to be part of our homework. And then one thing that I mentioned it at the very end. So this is my 6, 2. Can somebody give me a matrix B that is 2 by 2? Three, 4, 5, 6. So what did I do? Recall, I typed in first row in its own set of angular brackets, second row in its own set of angular brackets, and I gave it the array, entire to the array, a set of angular brackets. So you're supposed to have two set. Whoa! And then I didn't type in something correctly. Aha, what did I miss? What did I miss?
Commas.
Commas. This is my,
Yeah.
I taught this class in MATLAB about 6 or 7 times. I don't even count.
Yeah.
And this is what you can write in MATLAB. And of course, I keep doing it still. Again, you're going to type in mistakes. You have to be attuned to fixing them. So let's just print B quickly. Okay. Now, if I want to do matrix multiplication, okay, I'm going to call NP command matmul, matmul, of AB. Can I actually do this operation? A is 6 by 2, B is 2 by 2. Yes, that's why I designed B to be 2 by 2. So 6, 2, 2, 2. Inside dimensions are 2 and 2, they are equal. So number of columns of A equals the number of rows in B. And then I get a 6 by 2 as a result. Can I do the other way around? Two by 2 times 6 by 2. 2 and 6 are not equal, so it's going to yell at me. Shapes not aligned. Okay, so my dimension 1, again, dimensions start with 0. So dimension 1 is number of columns in A, is not equal dimension 0, which is number of rows of B. Yes? I was just translating, hey, these things don't have matching dimensions. So matrix multiplication, obviously you can work with and work through your homework. And then one thing that I want to do, you can transpose A. Oops. I'll just do NP transpose. Though I think I might have mistyped it. There we go. NP transpose of A. So now I flipped things around, so I have it 2 by 6. So you can do things that you're used to do. Okay. So now, as a review, we're going to do a couple of similar exercises, pretty much the same what we've done here, but in a new environment. And I think, but I don't know, that you will find that environment smoother to work with on a day-to-day basis. I do repeat that you do need to know this environment and the other one, because sometimes, so this is better for bigger programs, Spider. For quicker, smaller programs that are meant to be shared, like I'm going to share with you, that Jupyter notebooks, which I'm going to introduce, that work through your browser are better. Okay. And they're going to, I think, also be a smoother experience for you to submit homework with, because you can print them in a nice file together with the results, which kind of makes it a report almost immediately. So let's introduce that environment. So I will briefly go to the slides just to do a couple of introductions. So this is a web-based interactive computing tool, and it works through the browser. What is good about that is that everybody does have a browser on their computer or their phone. So in that sense, anything working or having a browser as a window into any kind of computing behind is useful. Okay. Here, you're working with Python. Python is already there on your computer. It's not a big deal. Where it might be a big deal when you're actually logging to some remote computer that is way bigger than what you have. And you're running some large calculations, it's useful to have that window through the browser to reach that remote machine. So as such, the tool is kind of much more flexible than most of the environments. So that is the beauty of having the browser. Second thing, browser underneath has what's called HTML code. Most of the web pages you're looking at are designed in HTML. So you can technically surround your code with anything that can be presented in HTML code, including pictures, figures, and all that stuff. So you can have your code together with nice presentations of the results from the code. And that's a nice flexibility. However, sometimes this is an additional software layer that translates stuff that you want to compute into something that you're seeing. And sometimes that translation, just like in human communication, doesn't always work smoothly. Okay? So be attuned to that sometimes you have to restart it, or it's a little cranky on Friday morning when your computer hasn't been restarted for a while. So just work with that. Okay? But when it works, it's really much nicer, I think, than the regular environment. Okay. So one also nice thing, and you don't have to know much more about it, but you can take it, and I'm not going to ask you to make your report super pretty, okay? That's fine. But you need to know that you can if you want to, or it's important for some other project in some other class. So what it has cells, so-called cells, that are code, that are just code. And then there are cells that are called markdown that can be some very nice text. Okay? And the text can be formatted in all kinds of nice, so you can have actually fancy mathematical formulas together with your code. And that kind of flexibility does not exist in Spider. Okay? So that's just something to have in mind. Don't worry about it too much, but you can take this to a very nice type of reporting if you want to. Okay? And again, there's this benefit of storing both code, results, and comments together. And you can also easily share it because you're sharing things through the browser. So let's try it out. Note that Jupyter Notebooks will have a different extension. It's going to be IPYNB, so IPython Notebook, IPYNB. Regular Python code is .py. You will be able to go back and forth. So the notebook that you store from Jupyter will not be something you can execute in Spider. Okay? However, from that notebook, you can strip it down and take only code, and there's a way to save it as a .py file that you can execute in Spider. Does that make sense? So Jupyter Notebook speaks both English and French and can translate between them. Okay? Spider speaks only English. Yeah? Okay. And I speak also Croatian, but not French. So sometimes you will not understand me as if I was talking in Croatian. So there's that. Okay. So let's get more. So just be attuned to what is the extension of the file, because that will determine whether the file can be read or not. So let's open up Jupyter Notebook. And what I want you to do is just to recap what we've done so far. I want you to test, can we define a variable named a minus h and assign the value 5 to it. And I also want you to check whether a times b is equal to b times a. You possibly already know the answer. But I want you to create two matrices that are 3 by 3 on your own and a vector, and see whether you can perform a times x, x times a, and what is the shape. And I want you to change the shape. So this is the little assignments to basically recap what we do, but let's start Jupyter first.
Do we still have to include NumPy as well?
Yes. So I'm gonna, Spider remains in its own little thing running on my computer. I'm going to start a Jupyter, and watch out, there's Jupyter Lab and Jupyter Notebook. We want Jupyter Notebook. Lab is similar, but frankly, I haven't worked with it much, so I don't know. So you will see what Jupyter does. It's working in your browser. So this is another tab in my browser. My Jupyter is going to my base default folder. Okay. So this is where, for instance, all of my UTBox files are in BoxSync. So I'm going to go there because that's where I want to store. So I'm going to go and navigate to the folder. You navigate to your folder where you're storing scripts from this class. And here I got to go to, I have way too many folders, but oh well. And then Python scripts somewhere, here they are. Okay. So now what you want to do is say, hey, let's start a new. I can execute all of these, which I have because I have them. I teach this class, so I prepared for it, okay? But you might not have it. So you want a new Python 3, okay? You can, from here, actually create a new folder, terminal text file as well, but we're interested in Python 3 notebook. Name it what you want to name it. I'm gonna say lecture. I'm naming this 2.3 exercise, and I'm gonna give it a date just to, today it's February 8th, 2019. Okay. You name it what you want to name it. And now I'm in the notebook. Here, this is saying input. This is my cell, and this cell is code cell, okay? If I name it markdown, it's only going to be text. I'm not interested in that. So any code that I was able to type into Python or Spider or whatever, I can type in here. Okay? So here is where I want you to test. First, actually, good suggestion. Let's import NumPy as NP. It hasn't executed anything yet. And let's try to define that a minus h is 5, is equal to 5. And to execute this, you can either say run here, or you can say shift enter or shift return, depending on which type of machine you have. So at that point, it executes that cell. Until then, you were just typing things in. And whatever result shows up here. And then it forms another cell, and you can keep going. So that way, you also have like a little bit of modularity within your code. So if you were working on your homework, I would have one cell for problem 1a, another cell for problem 1b, and so forth. And then the results show up right underneath. And then you just print that into a file. So you just use a print command from your browser and print it into a PDF that you then can print or submit online to Ningyu. Okay? Does that make sense?
Is it normal for it to look like this?
That's a terminal. That is not Jupyter. So, Ningyu, can you check?
It's still working, it's super slow.
Oh, it's just working on opening it. Okay. So, as you are opening these things, you will actually possibly see a terminal on the side that is kind of printing some commands as it's working on it. Those are all of the commands that are starting up this web browser business. Okay? So you can just safely ignore it, but just know that it's getting documented. Okay, so now I want you in this environment, I want you to do this part. So obviously here we had a problem because we actually cannot define a minus h. That's not a good name for a variable because it has an operator minus in there. So that confuses Python because it's trying to subtract a and h. And it cannot because it doesn't know what a and h are. Okay? So you cannot type in something like that. So I want you to continue with the exercise that is on the slides. I'm going to put the slides online. And I will also ask you to then save this code and submit it as some sort of a quiz. Okay? So you can, I typically will leave some time for you to complete this. You don't try to complete it in class, then you're done with it. But if not, I'm going to ask you to submit online later, at a later time so you can complete it during the day. Okay? All right, so let's work on this. For two scalars, we know that that the operation multiplication is commuting. And question is the same true for matrices A and B? I want you to create two matrices A and B of your choice, whatever numbers you put in there, that are 3 by 3. And I want you to also create a vector x and then do A times B, B times A times x, x times A. And I want you to check the shape of A times x and x times A. And I want you to change the shape of A. So those are 3 little assignments that I want you to work on. And then you and I will walk around and see how it's going. This is the PDF of the lecture. Yeah, let me actually install it. I can help out with this.
Yeah, mine is dark. It hasn't moved at all.
Y después esto era no, esto es línea. Porque estoy abajo. Sí.
¿Para qué?
Para que sean 3 líneas.
It's the internet using Google Chrome.
Pero porque es un ser humano. Ah,
So it is, it will say collapses the file.
Microsoft Edge.
So collapse is the, that's it. Yeah, it's open, it was open actually, it's just showing this. So, now, where's your,
Yeah, I do on desktop, and then I have Spring2019. Spring 2019, and then PGE310.
just kind of navigated it, and now we call it something that saved it under name. So here you just click on So what's the
So I say name.
So this contains the codes from the previous file. And what shape do you have? Oh, how does that shape? Pretty shape.
A dot shape, or whatever you name it, B dot shape, or NP dot shape, O, that's A, O, okay, O. Those two base.
So it's two for
1, 2, 3.
You don't.
9 by 1, entonces no es long.
number 1, 2. So
Tuple object is 9-1.
Pero le puse import.
It's not callable, because you can't give it the function shape
From here, right?
because you can't give it function shape. But tuple object is any kind of collection.
And so I could copy this code, right?
So you have to own this, right? Python. There we go. Okay, common mistake that I see. Let me address it. No, you're missing an equal sign. So when you want to say, I'm going to define a very small matrix here, NP array, or I'm just actually going to say 1, 2, comma, 2, 1, just to be quick, okay? And then I see this. I can't do 9, 1 here, I'm going to do 4, 1, okay? So if I do this, it's trying to pass 4 and 1 to function a.shape. But that's not how a.shape works. You have to tell it a.shape equals to 4, 1. So if you put this, it's going to tell you something tuple something something. Oh, NP, I did not import. I did. Oh, here it had a mistake, so it didn't import. Okay. So now I have to re-execute the cell that didn't run correctly. See, tuple object is not callable. I mean, good luck knowing what it means by that. But what it means by that, tuple is 4 and 1. You can't give it to shape as an object. You have to say equals to 4, 1. Okay? Because I'm trying to change the shape, so I'm assigning 4, 1 to that shape. Okay?
Creo que es porque dice equals separado.
So whenever I get my resolution, I get
You have to print it. Print it.
print.
So it's going to change shape. It's not going to print it for you unless you tell it to do that. Remember, it does precisely what you told it to do. Okay? Now, whether you know what you told it to do, that's a different matter. That's what we're learning here. Hundred times, there's no times. It has to be NP mathematics. Okay? So when you do times, another thing is, let me divide, I'm gonna define myself another function. And I'm gonna call it 0, 1, 0. And 0, 1, or something like that. Okay. So if I want to do print A times B, and I'm going to also print np.mathmo of A and B. Okay. So I have two, I'm working with 2 by 2 matrices, it doesn't matter. Whoa. Did I? Oh, I've changed the shape of A, never mind. Okay, so now I'm working with 2 by 2 matrices. Difference between A times B and matrix multiplication of A and B is that in A times B, it actually goes and multiplies corresponding elements. Okay? In each respective, so they have to be very same dimension. Okay? And in the second portion, it actually does matrix multiplication. So A times B is defined, but it's doing something different. It's not doing matrix multiplication. It's just doing corresponding places in the array. It just multiplies them. Which is useful sometimes too, but those are two different operations. Okay? And it's very tempting to type in A times B. If you actually do that in MATLAB, it's going to do matrix multiplication. So different environments have different ways to define things. The point I'm making is that you have to know what it's trying to do. And sometimes you, by mistake, type in a function that is a function. It's going to execute something. It's going to work in some cases. And that's the dangers of typing things wrong way or not knowing what it's actually doing. So matrix multiplication and actually times operator are two different things when working with matrices. If I'm working with scalars, then no problem. Okay, so in the last 5 minutes, so whatever you need to complete, you can complete a little later. I think by now we know all of the elements. I wanted you to do matrix multiplication. Okay, so that's a good point. So create, so for matrix multiplication. So just like in math, I would type in times, but I have to understand what is actually implemented in Python. Okay. So let's continue with some functions now that can give me larger arrays. I don't want to constantly type things in. I know how to type things in. 100 by 100 matrix, thank you, but I'm not going to be typing it. Okay? Because I'm going to introduce way more errors than I want to deal with if I'm going to type it. So first things, we're going to create some arrays that are kind of ordered arrays, but they might have any number of elements. So first function that I'm going to introduce is so-called linspace. So if I say that x is np.linspace 110, and then I'm going to print x, let's simply see what happens. I'm going to get 1, 12, 23, 34, and so forth, all the way to 100. So I got an array of numbers, one-dimensional array, that is between 1 and 100. There's 10 of them, and they're equally spaced. It's 11, 11, 11, 11, and so forth. Works with a pretty spacing, like here I can actually get integer numbers that way, but I can also put 300. Then it's not as pretty, the spacing in between, but it's equal. Okay. And this is useful because in numerical methods, my first job will be what we call discretizing the space. Because whatever I'm going to compute as a numerical solution will have just discrete values at certain points, and I gotta give myself those points. And my solution will look better the more points I have, the smaller spacing in between. So, but I want to have that flexibility of defining however many I want. So linspace gives me that. There's a function called arrange. So I'm just gonna actually go back to 10 here, just not to have that many printouts to look at. And then I'm gonna define another one. This is another function that is built in, NP, sorry, that is built in. 101, and I'm gonna give it spacing 11. Oh, and I did not tell it to print, so it didn't print. So it seems that it did the same thing, okay? Except that this time I specified, hey, have a spacing 11. And then what's variable is how many points it's going to be able to fit in. What happens if I actually put 100 here? This is a little twist. Python doesn't like taking into account that end point. When you say start and end, it doesn't include an end, which is annoying, but it doesn't. So it's not going to do 100 in that case. And you thought that you told it to do the same thing as before, but you didn't. You have to go to 101 or anything larger than 100. So I think it would even work. This is now testing it. What I'm doing now is a bit of a sensitivity testing to the function. I think I can just put 100.1 and it's going to do it. So as long as this endpoint is slightly larger than what I actually wanted to do, it's going to work. Peculiarity of whoever programmed that.
Would you say that again so it doesn't print the last
So it doesn't, whenever I say start and end doesn't get included. Okay? Just like when we were slicing a matrix. That end column didn't get included. Same thing here. Okay? So what I'm going to probably do is I'm going to create a short video, if I manage. We'll see how time goes this weekend. And post like a 10-minute video of the rest of the functions, and then we're just going to, next time, we're just going to have a little assignment in class. Okay? If I don't get to do it this weekend, so work with me here. I didn't mention 2 toddlers. Then we're just going to work on it in class. But that way we can actually work on a little problem as opposed to me just going through functions. Yes? Yes, and I believe Mingyu has created a quiz where you can upload the file. So the file, that IPYNB file, you can just upload to Canvas. And there's a quiz posted. Can you send in a little note, please upload? Send an announcement. Yeah.
And when is it due?